Gentlemen, what we're looking at here is factoring part 2. I want to go back to the previous day's handout, which is the beginning of your handout, where it asked for you to give an example of a trinomial that's easy to factor. There are a couple of trinomials that are easy to factor, one of them being a perfect square trinomial, so x squared plus 6x plus 9 is easily factorable. When we factor a perfect square trinomial, we know it looks like vertex form. In this case, if you square root the x squared, you get x. If you square root the 9, you get 3. And we know that we put addition because there is addition here and addition here. And you can look at the shortcut for expanding this, that is squaring the x, you get x squared, squaring a positive 3, you get the 9, and then to determine the middle term, you can multiply x times a positive 3 and then double it, and we know that works. Another trinomial that's easy to factor would be something like x squared plus 8x plus 15. Just fix that up quickly. 8x plus 15. The reason why that's easy is because in this case we're looking for, we know factoring this would look like this, because foiling, when we FOIL x times x would get me my x squared, and then there are two numbers that would go here that when multiplied the product would be 15. We know 5 times 3 is 15, so in this case we'd have plus 5 plus 3, because those two numbers multiply to 15, but they also add to a positive 8, and that's as simple as that. And we'll look at a couple more examples of that here in part 2. So I apologize for the blanks being tabbed over in the wrong area on this video, but bear with that. So again, here we're looking for two numbers to factor this. We are going to have root form. We're looking, and the a value here is 1. So we're looking for two numbers that multiply to 12, positive 12, and they also add up to 8. And we know 6 and 2 is 8, and 6 times 2 is 12. So we have positive 6 and a positive 2. It doesn't matter if you wrote positive 2 and then positive 6, it still works. Next example, we're looking for two numbers that multiply. Again, we could start off like this because we know we have x squared. Two numbers that multiply to negative 18 and add up to negative 3. In this case, we're going to have one number being a negative, and the next, so we'll have subtract something here, and one has to be addition, because negative times positive gives us negative. In this case, we know 6 times 3 is 18, so we're going to have a negative 6 and a positive 3, so that our sum total is negative 3. Okay, so the last one here, or C, x. All right, two numbers that multiply to 21 and add up to positive 10. Positive 7, positive 3. You may want to pause the video and try the next few on your own and take it from there. And then come back to the video and see if you got the strategy down. So I'll do these fairly quickly now. X, x. Two numbers that multiply to 35 and add up to 12 are 7 and 5. Two numbers that multiply to negative 2 are 1 times 2. So I know I'm going to have a 1 and 2. The only question is, I need to have one negative, one positive, but the total has to be positive. So the 2 will get the positive, because when I add them together, I end up with positive 1. Here I'll have x, x. Two numbers that multiply to negative 12 and add up to a negative 4. 6 and 2. In this case, I need a negative 6 and a positive 2. Here, somewhat the same, but there are two steps. We're going to take out the GCF first. The GCF would be negative 2. We don't want to have a negative x squared in the bracket. So first, we'll take out the GCF, and we'll get x squared. Now careful here, because we took out a negative 2, negative 2 times a negative x will get us a positive 2x. And a negative 2 times a negative 2 will get us our positive 4. Now we've got a trinomial, and we have a trinomial in the brackets here, and so we'll say negative 2, and now we're going to factor that trinomial. So we're looking for two numbers that multiply to negative 2 and add up to negative 1. And the two numbers are 1 and 2. And so in this case, we want the 2 to get the negative and the 1 to get the positive, because when they're added together, we end up with a negative 1. If I take out the GCF here, I get 6 times x squared minus 7x plus 12. And then we're going to factor what's in the brackets here. And I get, looking for two numbers that multiply to 12 and add up to negative 7. They have to be positive 12 and add up to negative. Well, negative times negative, negative 4 and negative 3 add up to negative 7, but they multiply to positive 12. And that's that. So a little take on this and how we can relate it to graphing. If you factor the right side of this equation, we first take out the GCF, which is 2. So we get x squared times negative 2x minus 3. And then we're going to factor that, and we get x here, two numbers that multiply to negative 3 and add up to negative 2. So one will have to be positive, one will have to be negative to be able to multiply to negative. And we're looking at a 3 and a 1. We want a negative 3 and a positive 1 so that we can get a negative 2 as a sum, and that's root form. So the x-intercepts are negative 1, 0 and 3, 0. And I'll put those on here. They are 3, 0 and negative 1. Okay. The equation for the axis of symmetry, as you will recall, is you add up the roots and divide by 2. So negative 1 plus 3 divided by 2 is 2 divided by 2, which is equal to 1. So we know that our axis of symmetry is x equal 1. I don't need to graph that, but it will help us find the vertex. So we know the vertex is 1 something. So what is that number? We sub 1 in for x. We'll do that over here. So into the equation. The original equation was x plus 1, x minus 3. So 2 times 1 plus 1 and 1 minus 3. 2 times 2 times negative 2, which is negative 8. So we're at negative 8. And if I want to draw a graph, I can also find x plus 1. I could sub in 0. And I will get 2 times 1 times 3, which is negative 6. And so I know that 0, negative 6 on my parabola is a point. Now I can graph. I don't like that. Let's try that again. A little easier. Okay, last question. To find a fully factored form for the shaded area, we want to multiply the length times the width of the larger and subtract length times the width of the smaller. Okay, so the length of the larger is 2xy times x plus 3, and the smaller is x times y. So we're subtracting x times y. First, we're going to distribute this, or distribute. So we have 2x squared y, and then 2xy times positive 3 will be 6xy, and then of course minus xy. And then we have like terms here, so 2x squared y plus 5xy, because 6xy minus xy is 5xy. And we just want to see if we can factor this. Is there a GCF? Well, numerical coefficient y is none, but we do have x squared and an x here, and a y and a y. So we can actually take out one x and one y. And I can multiply that by 2. Again, one way of looking at this, there's two ways of looking at this when you're factoring. I can take this and divide it by the GCF and see what I have left, and I'll have a 2x left. Or I can ask myself, xy times what will get 2x squared y. Either way works. In this case, I have plus 5, and then that's it. So your answer is xy times 2x plus 5. You could double check. Again, xy times 2x. xy times 2x is 2x squared y, and xy times 5 would be positive 5xy. And that's fully factored form. All right, thanks for tuning in to part 2, and we'll see you in class.